record on. There we go. Happy Monday, each and every one of you. Welcome to another class with yours truly, lecture 13. Lucky number 13, because I get to be with all you today, learning about databases and SQL. Why did I pick this GIF? I don't actually remember. I'm pretty sure I was making this one in the back of a van at one time. And I was like, this looks like a funny GIF. Why not do that? I'm pretty sure I had something to say about it, like doing two things at once, but I don't remember exactly what my talking point was. So I'm going to just let you all have, oh, what's his name too? Oh, what?
Beta.
Thank you, Beta. Yes. Funny story. I apologize. My old roommate when I lived back in California, one of my three roommates, because we all had to split a three home because that's how we could afford rent back then. He watched every single episode of Star Trek, and I was always on the couch anyway, just watching too. So I have now, by what do you call that? By affiliation, know every single episode of Star Trek, but I of course forgot Beta. Anyway, I'm rambling. Let's get going here. Our announcements. Our announcements here are, first things first, I need to, of course, apologize to you all. The long-awaited videos are posted. That's for lecture 12, our last lecture, as well as the studio. I apologize for not getting those out there sooner. Usually I'm more on top of the ball, but life was a little bit chaotic, as is everyone, so not a big excuse there, but I do apologize. They are there now. Well, they're not there now. They'll be released at 6 p.m. and 6:15. just because it takes a little bit of time for the processing to go through. So you should see them released at those two times. Of course, this lecture video and the studio will be up tonight also. That being said, this isn't an announcement, but there will not be another live studio video or live studio recovering. It will actually be a video on YouTube. So take a look for that at 8:15 tonight. It will be released then. One more announcement too, please start digging into assignment number 4. If you have not started, or I'm sorry, that's actually a little bit premature. I apologize. I don't know why this one's in this lecture, but make sure you're working on assignment number 3, not on assignment number 4. Assignment number 3 is going to be due on the 25th. So that's going to be next week. So if you have any questions about that, reach out to those colleagues, out to me, out to your TAs, TFs, and get those questions answered. Thanks everyone also who is scheduling time with me just to work through those problems. It's always great to just go one-on-one and also hear how everyone's learning and everything like that. All right, that's the announcements today. Any questions before we start going? Anything at all? All right then. So if you are going to be following along today, just remember too, I'm going to be using MySQL Workbench. If you want, feel free to get it open, get it ready. But I'll be walking through all that today as well. But just want to give you a heads up. Before we dig into any of that, as always, got to start out with some pets. Let's just talk about some pets that we've had. We've been working with some pets through the weeks, aka always, and most common is our dog. We're always using dogs. We also have our cats, and then we have our rabbits. Where am I going with this? Hold on for a second. We have pet types. You and I are human. So we look at this and we know that the pet types are dogs, cats, and rabbits. Great, we understand that. But we know that we have a colleague with us all the time, which is a robot, our computer. Computers and humans are not the same, though sometimes robots like to think that. They are not human whatsoever. They are different. So when we tell or ask a robot, hey, these types, dogs, cats, rabbits, when we say that to a robot, it will have no idea what you're talking about. This is because computers, robots, don't work like we do, where we have these kinds of names associated with this animal or this type. What computers think on, as all you know, is numbers. So if we were talking to a computer, we should be using numbers to represent human objects, such as a dog, cat, and a rabbit. That's how we can translate this. Now, where am I going with this exactly? How we actually communicate between a human type or a human name and a computer type and what it knows about numbers is a thing called an enumerator or enumeration. For short, it will be called enums. This is a very popular thing in Java because it's a way for us to make types or categories easily with a human representable name, but a number beneath it. Therefore, a computer can also understand at the same time. So if we were going to do this or create an enumerator or a enum, what we do is we say public, and then I want to bring in a new keyword here. It's going to be called enum, E-N-U-M. And then after that, we actually have the name of the enumerator. In this case, what we were just talking about is pet types. Now, the fun part in here is that this is where you get to create those human representable names. So we'll bring those back in, dog, cat, and rabbit. Now, to us, this is easily noticeable what we're trying to talk about in our code. And if someone else looks at our code that's working with us in our team, it's easy to see. We know what a dog is, we know what a cat is, we know what a rabbit is. But again, we got to work with our colleague, work with our close friend, our computer, our robot. So underneath all of that, we actually have numbers there. So in the computer's mind, dog is a 0, cat is 1, and rabbit is 2, and we can utilize that within our code. Now, this helps us, again, create those types, but also provide structure in our applications. If for some reason you wanted to provide dog inside of code, we no longer have to hard-code it, aka make it into hard-coded strings. We have to actually have this representation inside of this object thing or inside this structure to represent dog in a more structural, not really powerful, but more structural, more stable way than just using strings. So if you're asking yourself, what do enumerators do? They offer us the benefit of actually creating a more stable structure when we're referring to things that won't change. Now, one thing about enumerators that I want to talk about is that once you create them in your code, you can't update them or change them dynamically when your application is running. They stay just like that. So if you need to add a category, it has to go in before the application is ran. This right here is enumerators. It's a very, very simplistic topic per se, compared to some other things that we were doing beforehand, but it's a very important and powerful one as well. So right here, I'm going to pause because also I need some water. Any questions about this or what its use could be?
Kyle, are there any upward limit to or practical limit for things you can list in an enum?
So the amount that can be listed in enum is basically numerous. So it's potentially limitless. Of course, there's a limit at the end, but it's hard to ever reach that. Now, if you're asking how many types can I make or how many enumerators can I make in an application, that's also limitless too. Make sure that you are keeping it, having a reason that you're creating an enumerator. So make sure that you, like if you have specific types, that's what typically you would do. You don't want to get too granular because then it just gets confusing. Think of it as a way of organizing stuff, or like those little plastic compartments, a lot of plastic compartments. A few of them to hold your stuff is helpful, but if only you have one big tub, it's hard to find stuff. If you have 1,000 small tubs, it's impossible to find something. So it's good to try to find that medium in the middle when you're creating your enumerators to try to make it manageable, but also helpful at the same time. Now, does that kind of help, Mark?
Yes. With experience, I'll get a sense of like, don't put more than 15 or just whatever the situation calls for.
Exactly. And why I can't offer an exact number or anything like that is because it's a gray zone. It's depending on the team that you're working on, your application you're working on, and how they feel. Some people like to put everything in enumerator. Some people like to put one per enumerator, but there is that Goldilocks zone right in the middle. Awesome question. Anybody else?
Yeah, can you break down again what it is? I know you said it's like a way to make, you say human name types or something. Can you elaborate on that just a little bit more for me?
Yeah. It's a way to provide structure for a human term, but also giving it a number. So here we are talking about saying that it's a way to create categories or a way to make any kind of typical word useful within the application. And to help us out a little bit, let's go ahead and open up IntelliJ and just take a look at one. So if I was inside of here, what I'm going to do is that I'm going to just go ahead and create a new package here. Now, we don't have to do this for enumerators. I'm doing this to separate us away from the MVC model because I don't want to put in controllers. I don't want to put in models. So I'm just going to call it my enums. just like that. And I'm going to right click, press new, and then I'm going to say Java class. What I want to do is come down here and press enum. It's going to help us out a little bit. So I'm going to say pet types and press enter. So I'm coming here and automatically create that public, then enum and pet types. In here is where I can actually create something. So I can say dog, which the typical, excuse me, the typical way of preparing an enum is in all caps. Sometimes you'll see it a little different. Again, it's all depending on your team structure, but I usually put it in all caps there. So we say dog, cat, and then rabbit. And I might be, there we go. Let's stop that. 2. So once we go ahead and create that, what we can do now is go into, say, our user class or something like that. And what we can do is we can say private pet types favorite pet. Now, typically you could save this with a string, right? You could just put dog in strings or something like that. But remember, you can maybe mistype dog. You can, somebody could put in all lowercase or all uppercase, which is technically 2 different things. This is providing that structure so we know what exactly they're trying to say. So what we can do is we can say, if I just wanted to set it down here, this dot favorite pet equals pet types dot dog. And now I'm able to come into my user class and actually see, okay, what is their favorite pet? And I know it has to be one of my 3 categories, dog, cat, or rabbit. So this is a way of providing that structure instead of hoping us and our other programmers spell dog correctly every single time. So Eva, does that kind of help a little bit?
Yeah.
Okay. All right. We can go through it a little bit more if you want.
No, I was just grabbing a cookie. Never mind.
Okay. Okay. All right. All right. Just want to make sure.
It works.
All right. Anybody else on this? Going once, going twice. Eva, I hope you have enough cookies for the class. 3 times.
Actually, you do. I went to Walmart.
All right. So that is enumeration there. Okay. Let's see here. Any last thing on that? Looks like we're all good there. Cool, cool, cool. All right. Then let's go ahead and start diving into more information. I can barely see that. There we go. Okay. I'm going to go ahead and cool. All right. Let's talk about data. Now, we're still in the MVC model. We're moving away from enumerators, bring it back to MVC. You all know about this. It's our UI, user interface, our front end, our client side. All those words mean the same thing. When I'm on my UI and I type in a website that I want to go to bing.com, whatever, the second we press enter on that bar, second we press enter on our URL bar, we send out a request. And that request is accepted by our controller, aka our Java server, what's running our application on it. That controller takes it in, sees what you want, builds that template, whatever it wants to do, and then we hit it back with that response. Now, you saw in the last lecture that we were able to add dogs into that array list. We got to do an awesome list of our favorite dog names, whatever. Yes, we changed the world with our application. But the second we turned off our application, all of that information went away. That means if there was ever a power surge at one of the big names out there like Google or Facebook or something like that, and those applications went down, all the data would disappear. Now, does that sound like a world we want to live in? Because I don't want to go through the process of building a Facebook again because I barely remember doing it the first time. So they came up with a solution to help us out with that, to make the data persist. And that's what we're going to be talking about today. With our UI, talking to our Java server and sending back those requests, when we actually want our information to truly persist, we introduce the concept called a database. So my Slack just went completely down. There we go. Awesome. So what happens is that that information comes in the Java server, it does its thing, but if it wants to remember it, it sends it over to the database. But it works both ways. Once we send data over to the database, information can actually come back as well. So when our Java server needs that information back, we ask the database and it sends it back to us. This allows the information to persist even when our Java server, the middleman here, goes down for whatever reason. The information stays around in this database here. So what exactly is a database? You've heard databases before, even if you weren't even familiar too much with programming or with concepts, you've heard database on the news. But what exactly is it? Well, a database is a concept. It's about where information lives. It's very, very general. It's like saying, what did you have for dinner? And you said food. If you ask me, where's the information saved? I say database. But what I'm trying to get at is that databases come in multiple flavors. There's multiple ways to save information on the web. But in this class, the particular one we're going to be indulging on is called MySQL. That's what we're going to be working with. And you know it already by the MySQL workbench that you all have downloaded, right? Right. Yes. Awesome. So this is MySQL workbench. I'm going to go ahead and open it now. So I say MySQL workbench here. Go ahead and open that up. Hopefully it pops up here. Maybe it won't. Oops. Where did you go, MySQL workbench? Maybe it won't pop up. And maybe he just wants to have a bad day. It's having a case of the Mondays. There we go. Now you're back. Thank you. Now you made me lose my entire flow. All right. All righty. So this right here is MySQL Workbench. Of course, I'm on a Mac as always, but if you're on Windows, it typically looks like a little bit different. I'm in dark mode right now, so that's why it's all very dark and everything, because I'm a cool programmer like that, and I thought it would look cool. So if we're looking at this, what I'm going to do is that you should listen to Chris's exercise of walking through how to build your local instance there. Those are going to be through those exercises. I'll also have an exercise out tonight as well, and the studio should talk you through how to get that started. If you double click on the local instance, it will ask you for this password. When you are setting up your MySQL workbench and you create this password, do not forget it, because it is a nightmare trying to recover your password. In fact, you cannot recover it. You will have to reset the entire thing, and it is absolutely a struggle. So do not forget it. Write it down, get it tattooed, whatever you need to do. Do not forget that password. I'm going to enter in my super secret password. It's going to open it up, and we're going to see some things in here. So welcome to the panel. Mine's going to look a little dirty because it is still from the last unit or from the last class. I'm going to go ahead and clean it up just so there. I wanted to clean up before, but unfortunately, I-64 traffic had another thing in mind. So you have to bear with me here. There we go. Come on. If anybody wants some foreshadowing, just go ahead and take a look at these tabs. Yep, they're all over the place. A lot of dog toys. Oh my gosh. Almost there. Just need a little bit. Come on, give me something. There we go. Haha. Wow, my gosh, there's more tabs in my browser. Oh my. All right, we are cleaned up and we are good to go. So go ahead and take a look at this. This is what yours should look like. It should open up a query one window all the time. We'll talk about some queries and what those even are here in the future. You'll see administration. That will also play an important role as we move forward through our units. But what we want to really pay attention to today is this thing called schemas. I have a few here from the past. Don't worry about those, but yours typically would be empty if you're starting from scratch. Here, schemas are the concepts of what databases are. Schemas are where your information is going to be stored, depending on what that schema entails. So if we're running a pet store, we're going to have a pet store schema. If we have user jobs data, hint, hint, we're going to have a jobs schema as well. Depends on what you're doing. So schemas are organized by the topic or the context in which your application is using it. So in this case today, we're going to be working with queries, with the schemas and things inside of it. Let's go ahead and hop back to our presentation. Oh, I don't have my Slack open, so let me make sure I'm not missing anything there. See, we're having a question typed out, so I'm going to go ahead and pause here for just a moment. I've also just been, I know I didn't have any questions in the beginning too. I've just been shouting at you. I was like, I don't want to hear anything from y'all. Let's just get into it, into the thick of it. Oh, 2 people, yes. Are we officially entering backend programming by starting this? Or would all of what we've been doing in Unit 2 consider backend? For the most part, Java is considered a backend language. So anything you're programming in Java, like the controllers and everything like that, is technically backend programming. You're entering into the persistence layer, which is also part of the backend, but it's a different portion. So you've been in the backend for quite some time, using, again, those Java controllers and the MVC architecture. This is just entering into a new layer of it. Not like a scary layer, but I've got a really cool layer. So this is the persistence layer of the backend. I know, exciting. I'm excited. Kyle, is it normal to keep opening new SQL tabs to run commands? In the exercise, I just kept deleting my old code and running new code. What do the cool devs do? Mark, cool devs do what you do. An unorganized dev that just wants it to run is this guy. So I open up a new tab most of the time. So you can do that. Sometimes I'll just like be running really fast and I'll do like quick things and it just opens up a new tab automatically, which causes that chaos that you see. So honestly, just recycling, I'd say you're more environmentally friendly than I am. Just keep recycling that tab if you want to. But if you want to save that code, feel free to open up a new tab. Really, either way, it's kind of more just your preference than what the typical standard is. But good questions. I'm just a, what do you call that? I'm a SQL hoarder, apparently. So I apologize. All right, great questions, everybody. Let's keep going on. Let's go ahead and let's actually explore what this database thing actually looks like. But before we do that, as always, all new languages, let's start at the bare basics. Let's see how much we've learned up into this point. Everybody remember our old friend JavaScript? Anybody like really miss JavaScript right now? I know, sometimes I do every day. Remember these 2 things. We had const and let. These are our variable types, essentially. Not our data types, but the variable declaration types that we have. I just see everyone's like, yes, I miss JavaScript. I know, me too. Now today we have Java, who's not as cool, but unfortunately we're stuck with them for a little bit longer. But in here we have our variable types, or more of our data types, as more defined: int, Boolean, string, things like that. Now we're moving on to SQL. SQL is also a language in itself. So it's going to have these data types as well. And so if we're looking at Java here, direct correlation to int is just int in all uppercase. That's what you'll see there. For Boolean, it's actually shortened to bool, all uppercase. And then strings are going to be working with something called a varchar. A varchar. So strings aren't truly a concept in SQL. It's called varchar. Why is it a varchar? I actually forgot the real reason. I just think that they just wanted a cooler name. But I think it's variable char or variable characters or something like that. But anyway, let's go and explore it. We're going to take a closer look at this varchar thing that we keep talking about. So varchar is how we have strings. Is it cooler though? It's a little cooler. It's a little cooler. Kind of cooler name. So varchar is how we save this string representation of data. Now, a varchar, again, holds string information. So it's going to be numeric, it's going to be symbolic, and it's going to be just typical alpha characters as well. But one thing I want to show you is that, okay, varchar is there, but we can only have a set amount of characters within SQL. I'm going to pause there for a moment and talk about why I just said that. The persistence layer holds all of your data. So the data persists there for long periods of time. Now picture a database, any of the big data companies that you can think of. Think how massive, if you ask them how much data they store, how massive their database system must be. There is thousands upon thousands of exabytes out there. That is, I don't forget what even like the big name is that's actually out there right now. It's way beyond terabytes. I think it's way beyond exabytes. It's something now. It's like a zerabyte or whatever. But anyway, there is a ton of data out there. So where am I getting at this? Data takes up space. So databases need to be able to know how much space exactly you're going to be taking up so it can optimize itself the most it possibly can. So numeric values like ints already have a set amount of space they're taking up. We know that ints are 32. We know that longs can be 64 bytes, but strings can be 1 byte to a trillion bytes in Java. But in SQL, we got to be like, okay, we got to tell you exactly how much space to allocate for this character array I'm about to provide you. So what we got to do is actually we include a number inside of the parentheses there to tell it how much space to allocate in our database. So it knows where to save it and how much to save it there, so it can really, really make sure that there's enough room. Jason, the book didn't specify, but is there a character limit for Varchar? Technically, the limitation for Varchar is 256 characters. Now, that is for a Varchar, but there are some out there that allow you to do an unlimited amount of text, which is okay. That's fine to do a limited amount of text. It does take up more space. That's why we like to do the Varchars to a certain amount of space, just so we can optimize our database the most. But there are possibilities to do endless amounts of text. But yeah, 256 characters is the current limit to a Varchar. So 255 is technically the limit, so it's 0 to 255. Don't try to put 256, you might get an error. So is that why so many forms are limited to 250 characters? It actually could be. That'd be a smart way of doing it. I actually have a really good story about the YouTube, how oh gosh, what's that? Gangnam Style. Gangnam Style broke YouTube because of space allocation. Does Twitter have anything to do with Varchar, same number of characters? It could be. I don't actually know their database structure, so it could be, and that's why they want to do it. It's probably why they increased that amount. I don't exactly know, but good question. If you find out, let me know. But it would make sense of why forms are limited to that, so they can allocate that much space in the database. Also, they could just not want to process so much data too. See one more person typing, then we'll move on. All right. So let's talk about what we just talked about a little bit more in depth. Let's bring in days of the week here. Now we have days of the week. Do we need 255 characters for our database? No. What we do is that we look at the days of the week and we say, okay, what's the worst case scenario? I believe it's Wednesday. And Wednesday comes in at a nice Varchar of 9, right? N-E-N-D-N-E-S. Yeah, I got it right. I can't actually, Wednesday I could not spell until like I was like 20. But yes, Varchar, so we are doing days of the week. When we want to save it in the database, we don't want to do 255. We don't need to allocate that much space. We need to do exactly what we need. So we say Varchar of 9. So that's what we're going to do there. The original maximum coins is 255. That could be a different reason. It might not be a Varchar, but 256 is, oh, I forgot. I think it's 2 to the 8th? 2 to the 8th? I don't know, 2 to the 8th, 2 to the 4th, 2 to the 8th. I don't know. It's one of those two, but it's a certain amount of bits, and that's how much memory is in there and stuff like that. But anyway, yes, make sure you only keep enough space that you need around in your database there. So I'm gonna pause there just for one more moment here. Feel free to unmute yourself and ask any questions you have before we actually start diving into what this database thing actually looks like. We already talked about the variable types, but now let's see actually what the structure is gonna be.
So with the Varchar, the number of characters, that's starting at 1, not 0?
Let me think. So I think it technically starts at 0 and goes to no. That will be the number of characters you have there technically. I think it goes up to 255 because there's 1 bit, I think, used for like this, like the unsigned portion or something. I don't remember.
The
but
delete
I think
flag,
is it
maybe?
the delete? Okay, it could be. It's one of the flags. Yeah, you got me on that. But it's 255 is the max for Varchar. But no, this is how many letters are actually going to be in there, or how many alphanumeric symbols are going to be in there. So Wednesday is 9 characters long, so it's 9 here. So sorry about that confusion, Jade.
Oh, no worries. Thank you.
Absolutely. Great question. Anybody else? We keep moving. All right, we're going to do that then. Okay, so we've talked about this data type stuff. Let's actually talk about what it is. Let's visually see this thing. So what is a database? If you're looking at a database, picture a 2-dimensional grid. It is an Excel sheet on steroids. That's what this is. Just like an Excel sheet is, we have our columns. So we have columns, 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 and then we have our rows. Our columns are going to hold our data, and our rows are going to be all the entries of all that data. Talk about what I mean by that. If I wanted to create my dog, of course, let's build a database for it. Our columns are going to hold the information. So our column headers are going to say what that information actually is. So our first one is usually an ID. The ID is very important. Second one, we're going to have a name in there, an age, and then an owner. Now, this is just setting up a typical dog space. Nothing crazy about this just yet. But what I really, really, really want to pick on here is this ID field. This ID field is extremely important in SQL. All of our rows have to have some kind of identifier. Why is that? Because if you don't have a home address and someone's trying to find you, or if you don't have a phone number and someone's trying to call you, it's hard to reach you. You have to have some kind of unique identifier on your information so it's accessible, so we know exactly where to go. Otherwise, it's very hard to find exactly what row you want to know about. So our IDs have to stay both unique, and each row typically has to have one in our databases, or each table has to have one in our database. So in this case, our ID in this case just going to be 1, nothing crazy. Name, of course, is Stark, age is 7, and the owner is this guy. Then we're going to add some more information. We're going to have Fido here, age of 4, owner is Sarah. Now this is cool. This is what a typical database is going to look like. We have our IDs here that are unique. We have 1 and 2 incremented just like that. Our name of our dog, our ages, and our owners. This is all it is. This is what a database looks like. Like I said, it looks like an Excel sheet. So there's nothing too much to be afraid of. Most databases are these 2-dimensional sheets. Of course, there are different structures out there, but this is the one we're actually going to care about for quite a while. So let's go ahead and talk about what we're actually going to do with it and how we can actually create it. Let's create a place for our data. So to do this, we need to write something called a query. A query is basically politely asking SQL to do something for us. So we're going to create one now. And to do that, we're going to create the table and a schema. So to do that, to create a table, we start first with the keyword create. Next is the keyword table, and then the actual name of the table. This is the beginning of our query. It's saying, hey, I want you to create a table, SQL, called my dog table. But inside of there, we actually need to provide some more information. We need to actually provide the column names, the column headers. What are we going to actually be storing? So the first thing is I'm going to say a dog ID. It's the name of the header, name of the column. But one more piece of information, just like if you're creating a variable, we need to tell SQL what kind of information is going to be in that column. So I provide a data type, int. So I say dog ID, int. My IDs are going to be integers. Next, we're going to say the dog name, which typically in Java would be a string, but we don't have strings. We have varchars. And in this case, I'm going to create a dog name of 50 characters. Now, why 50? I chose it arbitrarily. I don't want to take up too much space for a dog name, but if you have dog names over 50 characters, we need to talk about what you're naming your dogs, because that just has to be a pain to spell on paperwork. Next, we're going to have a dog age. Of course, you can probably answer this. What kind of data type would an age be? If you answered int, you're doing great today. Regardless, you're still doing great today because you're still in this Zoom with me. And then finally, we have the dog owner. Again, this is going to be a varchar, but I'm going to give it more leniency on this one. I'm going to say, okay, maybe sometimes there are longer names for humans, so I'm going to give it 100 characters. And then I'm going to end it with a parentheses and then a semicolon to complete my query. Now, right here, you might have seen something that when I was going through my columns, one, the integers are easy to identify, an ID and an age, at least in this example. But the strings I had to make a call on. Now, typically in our assignments or in our exercises, they'll give you indication of how much to make it. But when it comes to this kind of stuff or allocation, it's hard to, you have to sometimes just make an educated guess on how much those characters should be. So there's a little bit of gray zone there. I'm seeing some questions here, so I'm going to pause. Is it safe to say creating tables like a constructor in JavaScript? In essence, but remember, constructors ran a lot to build those objects. A create table is actually only created once, and it persists. So it's a constructor maybe that you only create once, but constructors create objects, and this create table query creates a table. So there's some kind of connection. To clarify, if you have varchar 50, each dog name will take the same number of bytes no matter how long it is, or exactly what is the point of limiting on the character count? Why not make the character count 255 for everything? That's because if I said I want to make a varchar of 12, I always have an egg carton sitting in my database. So I always have 12 slots, no matter what row I'm on, I always have 12 little slots. No matter if I have 2 or 3 eggs in there, it's always 12 spots. So when you say, why can't we make it 255? That's because for every single dog row I make, I'm always going to have 255 slots allocated to that name or waiting for something in that name. So if I'm only using 4 or 5 of that 255, after 1,000 dogs, that could be a lot of wasted space. So that's why I limit it to 50. I'm thinking the worst case scenario would be, I'm guessing the worst case scenario would be about 50, which means that only a couple, there would be less empty slots than if I allocated it to 255. So what that does in the end is it saves us a lot of space. So I guess the best way to talk about that, and Katie, yes, give me 1 second. The best way to talk about that is when you say 255 or you say 50, it's always going to allocate that much space on the row, no matter how much you actually use. Go ahead and, oops. Oh, well. Katie, go ahead with your question.
Sorry, I was like struggling to type my question out into words. So once you create a table, I know you were saying it persists. So does that mean like it just always stays in existence? Like even if you like shut your program down or whatever, like it's always there?
Yes, so that space has always been allocated and it won't change. So in your system, it will, I mean, of course, when you shut down your database, it stores and optimizes it technically. But when your database is up and running, yes, it will always have that space allocated. And why it does that is, what if you change that, which is possible, we haven't talked about it, but what if you edit that entry and you need to use the full space? It wants to always have it there prepared for you. So that's why we have to be very picky, choosy on how much we include in that varchar.
So it's kind of like almost its own little program, kind of.
I mean, in essence, yeah, it's more just making sure the space that you reserved stays there. You reserved 50 characters for this entry. And it's the bouncer at the bar that's saying that, nope, no more people. It's only 50. It's going to keep these seats available if you need them, whenever you need them. So that's why that space has always stayed open.
So I have a question. So do we basically kind of guesstimate, if that's the word, like our own, like, you know, the varchar, the numbers? I don't know, because I'm still trying to figure out, I'm trying to connect. How did you just put 50 like for a dog name? Like I don't get.
Like I said, it's an arbitrarily chosen number. So I just guessed.
Okay.
And so what we would have to do on the front end, this might be something we maybe covered in last lecture, our maximum size for our dog name on our form would then only be 50. So we have to limit the user on the UI.
Okay.
And sorry if I'm bugging out there, but yeah, we'd have to limit the user on the UI, so we only save 50 characters in the database. But to answer your question, I just guessed. So it's a best guess kind of situation.
So it might be something like, I think somebody was joking in the chat that like, how do you fit all of that onto a dog tag? It might be a case where you know that like 20 characters will fit on a dog tag, so when you're making it, you make it varchar 20.
Right, right. And yeah, it's all case by case when it comes to this. So if you know that the machine only takes 20 characters, then you know your database can be a varchar of 20. But in the end, you kind of just have to ask the user, you're like, how big is your dog name going to be? Please don't make it bigger than this. That's kind of that validation you add on the UI. And that is how all these pieces work together. Any great questions, everybody, honestly. Anything else? All right, let's go ahead and see what this does then. Let's keep moving forward. All right, so when we actually press enter on this query, and we'll see this in a second, what it's going to do is that it is going to create the columns and the table itself inside of our schema. So it goes schema, and then we have our table. And this is what it's going to look like. Let's go ahead and do that now. We're going to go over here to MySQL Workbench, and we're actually going to go ahead and create. First, we need to create a schema. That's our first thing, because we don't even have a schema for us. This is all just the past. All right, let's go ahead and do this. What I'm going to do is come up here to the left-hand side and click this little canister looking thing. This is to create a new schema. So in here, I'm going to call it Awesome Pet Store. Is that everything I already have? No, I deleted it, but oh well. We're going to call it Awesome Pet Store. Why not? I'm going to say apply. And then I'm going to press apply here. What this is just saying is like, hey, is it okay if I run this code for you, create schema, whatever? Awesome Pet Store. I'm like, yeah, go and do that for me. Thanks, MySQL Workbench. And then it says it executed it properly with that little green light. If you get a red light, doesn't have a good day. Double check those errors. But if you get green light, good day. All right. So we go ahead and press close here. And our Awesome Pet Store has been created. I'm going to go ahead and click out of these tabs. So I try to start out a little bit cleaner than last time. And now we are in this query 1 here. So what we have was create table, my dog table. And what we're going to do here is what? What do we need to do? I want to create an ID column. What do I start with? Oh, and did I keep letting you? Oh my gosh. Now you all can talk to me. How do I create a dog ID column?
I will put a dog underscore ID and then integer.
We start with the, awesome job. We start with the dog, we start with the column name. And then what's next?
Integer.
INT in all caps. Not playing around with that. Make sure it's all caps there. Very good. All right, let's keep going. What we need to do is a dog name, and it's going to be a string, aka what in SQL?
Varchar.
Varchar. Very good. And we're going to make it 50. Just 50 characters, whatever. We can make it 20 if you all want. Up to you. And now we're going to do a dog age. What's the dog age's data type going to be?
Int.
INT. Very good. And then finally, we're going to say the dog owner, which we already know is a string, aka a varchar, and I just made that 100 in the example. There we go. All right, so what I'm going to do now is that once I write my query, I'm going to go up here and click the lightning bolt. Once I do that, I see an output action down here. Oh, I have no database selected. My bad. All right, so we're going to go ahead and take a look at this error. So it says error code 1046, no database selected for this query, which is correct. So what I have to do is come in here and I make sure that this is double clicked. Once I double click it, watch how it bolds. That's how you know it's actually selected. This will save you from getting this error. So now I'm going to go ahead and rerun this. And now I get the green button. So make sure your database is double clicked and bolded, the one that you want to work with, your schema, before you run your queries. Otherwise, it won't know what database to run it in. If you wanted to like actually do it, what you have to do is you'd say awesome, or you want to do it without double clicking and out bolding, or without bolding it, you'd say awesome pet store dot my dog table, and then run that. But it's already open. The table already exists, so that would be an error. But that's how you can do it without double clicking. Either one but if it's bolded, it saves you some typing. So it does help. All right. There you go, everyone. You just created your first query. And this is also the saddest part of the class, because I know this is like the last big concept we're covering is SQL. And so I get like a little teary-eyed, like I just remember when you guys like were just creating your first little const variable. All right, whatever, I'll cry later. Okay, so this is the query. Any questions on this before we keep going? We have a couple more queries to go through.
Hey, Kyle. When I
Yes.
try to run my SQL, it's stating that it's not compatible with my version of my Mac OS. And
So
yet all of them is for Big Sur 11. I don't think mine's that new.
Okay, so I actually haven't heard that error yet. So I would say follow up with your TA about it. If you need any additional help, feel free to reach out to me, and we'll do that more one-on-one.
Okay, thank you.
Yeah, absolutely. All right, any other questions? Okie dokie. Let's learn another query then. That one went so swimmingly. Let's do, I don't know, let's get some information in this database. That sounds right. To get information actually into our database, to actually use the database, how it was designed, we want to put information in there, aka we want to use an insert. Insert is how we inject information into the table, aka insert into both keywords and then the name of the table we want to insert information into. So insert into my dog table. Awesome. You're telling it I want to put data in there where I want to put it, and now I need to tell it the values, aka we use the keyword values. And then in there, we in the parentheses put what we want to insert. So we say 1, Stark, 7, and Kyle. What this does is it correlates with the actual columns itself. So it says dog ID, dog name, dog age, dog owner, and it correlates it appropriately from placement. That's a very big thing. So yeah, Jason.
Hey, Cal, I'm sorry. On the insert into line, wouldn't you also define which columns that you'll be entering values for?
You can. I think I'm going to try this out because it did in the past. Let's go ahead and run the insert because I'm not going to answer that one yet until we actually do it. Let's go ahead and run that actual query. So what I'm going to do is I'm going to come down here. I'm going to show you all how to do multiple queries inside of one file and run it that way. So for this, talk with me. How do we put information into our database? What keyword are we going to use?
Insert.
Into.
Very good. Insert and then into. And then the name of the table that we want to do it. My dog table. And then we're going to say values. And then the values I want to do. So I said 1 Kyle, and I put it in double quotes because it's a string. My dog age, which is 7. Oh, I'm not the dog.
Is it backwards?
Dog.
Okay.
Yeah, there we go. Yeah, I'm not the dog. I'm the owner. Well, at least one day. It's Kyle, there we go. And then semicolon. And let's go and try to do this. So to just run this query instead of just doing the create table and then this one, I'm going to highlight it. Once you highlight it, you can come up here and click the little, there you go, the little lightning bolt with the cursor icon on it. So it says, hey, run just what's highlighted. That's what I just did. And we see it's a successful insert. Now, Jason, I want to do this just to make sure that this version is still staying consistent with what I know, that if you're not doing different columns or have something out of order, it will just know it by default. If you want to insert just into one column and leave the rest blank, you can put it in those parentheses. Or if I just wanted to say like, okay, maybe I don't want to put the ID in there. I just want to put my dog name, what is it? Dog age, and then owner name, something like that. That's how you can, yeah, I had the right. So you can insert it, a more custom insert, if you will. Is
So
how you do this parentheses.
if you don't specify it in there by default, it'll go by with whatever it's set up as far as when you created the table.
Exactly. By default, it's going to just say, okay, dog ID, which you can still do this, absolutely. I was just cutting a corner there and I apologize. So no, you can absolutely run it like this too. And we'll just go and run it. We'll just have 2 inserts of that same information. No bet, or not a big problem. Did I misspell that?
Owner
Oh,
name doesn't exist. It's dog owner.
Yeah. Thank you. Very good. That was a test and you passed. All right. Dog owner. Awesome. Let's try to do that again. There we go. Oh no.
You have 4 columns and only 3 values.
That was a
Mismatch.
bonus. That was a bonus question. You got that one too. All right. And we're going to say IT of 2 here. Just because this is going to be our second insert. All right. 3rd time's the charm. There it is. Green light. All right. So yes, we can do it either way. And I did want to show you all this too. So awesome question there, Jason. Any other questions on this before and to answer your question, Katie, we can see it as a table and we'll do that next. Any other questions for that? All right.
Kyle?
Yes,
how do you, what do you call it? Like get the schema involved with your query? I'm trying to do that, but so far I haven't been able to do so.
Say that one more time.
How do I add the schema in so I can actually start running queries?
Yeah, so to start adding the query schema, you're gonna come up here to the to this little canister here and click on that, and it will say add new schema. And then you'll go ahead and just fill out the schema name and press apply.
Okay.
There you go. Awesome. All right, so let's go ahead and hop over and see this table. So what I'm gonna do is I'm gonna right click and I'm going to say, I always forget this one. Oh, and some tables. Oh, you know what I need to do? All right, I forgot about this little quirk of MySQL Workbench. So we go over to tables and we see that there's nothing there. That's not true at all. We need to go up here and make sure that we click this little refresh button. Refresh your stuff often. If you're creating stuff, it will not refresh it for you. If you delete stuff, which we'll talk about in a bit, it will usually refresh it for you, but regardless, always refresh it. Refresh as much as possible. Once we refresh, we're able to come into our tables and now we see our dog table here. And again, I did that by clicking the refresh in the top right of our schemas window here. So when I come over here, I get 3 little icons. I'm gonna click the far right one. Wow, I forgot my lefts and rights. 50-50 shot. I am going to click that and it brings up this table on the bottom and I see 2 entries with column names: dog ID, dog name, dog age, and dog owner. And I see Stark and Stark, Kyle, Kyle, and with those ages. So that's how we were able to do it. Now, this right here is the start, and I think I have an example of this too, but I'll just call it out. How we did that was through the select. Use that select keyword. Technically, Mark, they don't have to be uppercase. They can be lowercase, but by typical standard, we uppercase them. But you might see some that are lowercase. Yeah, absolutely. All right. So, okay, cool, we're good. All right. Do you have to enter an ID every time, or is there a way to automate that? Maggie, what a great question. Hold on to that for one more lecture. But yes, there is a way to automate it. Pinky promise, because that would be a pain. All right. Let's go ahead and keep on keeping on. So we're going to go ahead and bring in now. So I want to talk about, or we're going to go ahead and talk about now, what if, for whatever reason, I make a mistake or our program makes a mistake and we need to change the information in our table. In order to do that, we use the keyword alter. Alter allows us to edit an entry inside of our table, aka we're going to alter a table, and then of course we provide the table name, the location, or what we want to actually edit. After that, we say we want to now maybe add an entry in there. And we say that, okay, on this table, I want to alter it. I want to change how it looks. So I want to add a column to it. So if I want to alter my table, I want to add, I apologize if I didn't mean to, I'm realizing I said entry. If we want to add or edit our table, we use the alter and we want to add a column. In this case, we're going to say add, and then I'm going to give it a new column called isGoodBoy, and it's going to be a Boolean. So for this one, what happens after that is that a new column is created, and it's called isGoodBoy, or isGoodDog, excuse me. Now, when this happens, and this is a very important little quirk again of MySQL that you should all pay attention to, is that we already had an entry in there. When that happens, null is automatically placed in that entry. Why is this something to pay attention to? Because if Java's grabbing information from here, we need to know where our nulls are, because we know nulls can be dangerous at times. So know that our information is null if we add a new column to a table that already has entries inside of it. Now, this added is good dog in there. But what if we didn't want to truly have that as a null? We don't like nulls in there. And also Stark is a good boy, or is a good dog, and I want my database to know that. So to change this entry, what we do is we use the keyword update. This is how we're going to edit an entry. So we say update, where we want to update it at, the table name. And now we use a different keyword called set. I know there's a lot of new keywords coming at you, so don't feel like you have to remember all of these like at right now. I would recommend just writing down an example of each of these queries and just seeing how they have it all structured. The painstaking thing about MySQL is I need it in a particular fashion to do the update of the query, and all these little keywords can get confusing. So set is the new one. It's saying, hey, I want to update my table and set is good boy or is good dog equal to false. Now this is easy, but we said, hey, I want you to set is good dog to false, but I want you, or you also need to denote what entry you want to update. So we use another keyword. This one is called where. Where is the start of a conditional in SQL? We're saying where something equals something. In this case, I want to say where ID equals to 1. I apologize for the typo here. It should say dog ID equals to 1, but just want to get the point across that it should be dog ID equal to 1, and that's our conditional there. So this is a lot, but I want to give you a little bit more. One more thing, when we say false in SQL, it's not necessarily going to set that value to false. You're going to see it in a different fashion, kind of what you saw today in the enumerators. False is a human concept, it's a human word. In databases, we save the number. False is going to be a 0 in the database. False, in any programming sense, false is always 0 and true is 1. So this is a lot. Let's go ahead and actually update our database here on the left-hand side and get that going. So the first thing was alter. So I just deleted that select. So what I want to do is alter table. What do we call this? We called it awesome pet store. Oh, no, sorry, awesome. We called it my dog table. My dog table. There we go. Alter my dog table. Oh, I always forget this. See, I told you, don't feel bad if you don't remember the keywords. And what we want to do is we need to what? Actually, I'm going to turn it over to you. It's the best part about being the instructor. It is add. Very good. Awesome, awesome. Add, and then what is next?
Is a good boy, bull.
Yes, exactly. The column name. So is good dog, and then we say what the data type is going to be of that new column. So we say bool, and then semicolon. There we go. Make sure my schema here is bolded, and then I'm going to go ahead and run this. Come down here, and I see that I am all good, I think. I can't really tell. It is good. All right, there we go. Zoom's in the way. All right, awesome. Once I do that, I'm going to say, now when I want to see my table and I don't want to go and click all those buttons, what I can do is say select asterisk, which means get me everything from, and then I say the table name. So in this case, it's going to be my dog table. There we go. I'm going to just highlight this and then run it separate. There we go. And that gets us. Like I said, is good dog is now a column here, and we see null inside of those columns, inside of those entries there in each row. Where those nulls can be dangerous. So let's go ahead and now we're going to change that entry. What is the keyword if we want to edit an entry in a table?
Alter.
Update. Very good. I'm going to say update. And then update my dog table. So we say where we want to actually update it at. So we say the table name, And then what's the next keyword we want to use?
Set.
Very good. Set, and we say what exactly we want to set. So we say is good dog. And then we want to do a particular entry. So when we want to do a conditional or a particular entry, what's the next keyword?
Where?
There we
Dog
go. Where
ID.
dog ID equals to 1. There we go. Now, if you're probably asking, or if you're asking yourself, what happens if I don't put where there? What happens is that I keep getting red. Why do I keep getting red?
You have to assign the value. Yeah.
Is good dog equals false?
Oh, thank you. I was like,
I think that's what everyone was trying to say.
Yeah, thank you. Yes, where false, there we go. I should provide that value. What are you doing? Oh gosh, okay, you are using safe update mode. Oh, give me a second here. Yeah, turn off safe mode. If you get this, it's typically on a Mac. There's two little caveats to turn off safe update on MySQL. Go. We're gonna actually just go through this. Yes, you can also run this command here. Highlight that. Make sure that one works because I think there's usually two I have to run.
Hey, Kyle, can you
Yeah,
move
there
your
you go.
screen over?
Oh, I think it's as big as it can be. Is it off the screen or?
It looks good to me.
Okay, cool. So this is it right here. If you get that safe updates is on, run this command here. Oh, Mark, thank you for that. But yeah, this is it right here, and we'll just turn it off on the schema. So sometimes you have to do that. For Macs, I'm telling you all now, if you are on a Mac, and when we start working with times, you might get an issue there as well. Of course, Central Standard Time is the one that causes issues. So just an FYI on that. All right. So, but we'll cross that bridge when we get to it. Okay, so now we have updated that. I'm gonna go and run my select here. I'm gonna run that, and we see that good dog is 0. Awesome. Just to show you real quick that if we set it to true, we say ID of, jeez, wow, I can't spell the day. Stop it. ID of 2, which means I'm gonna set the second entry there, and I run this. What happens there? I'm going to run my select once again. We have 0 for false and 1 for true. So there we go. All right, let's keep going on. I'm noticing that we're getting close to time, so I'm going to keep going a little bit. If you have a question, feel free to type it in that lecture question channel, and I will get to it. All right, where ID equals 1. So this is how we update our entries inside of our table. We have a few more queries we need to go through, so let's do that. So, it just disappeared. There we go. All right. So we want to get our data. We've already seen one way how to get it. What we did was that we used that. So we have our entries here and everything like that. There we go. How we got that information back and we actually saw that table is using that keyword select. Select. That's how we're going to get data back. If we want to get all of our data back, we say asterisk, and then we say where we want to get it from. So we use a keyword from and then the actual name of the table that we're looking for. When that happens, we get that entry back, that query result. That query result's going to look a lot like that right there. So our dog ID 1, Stark 7, Kyle, and is good dog 0. So that's how we got that. Of course, in our example, we got it back 2 because we have 2 entries, but so be it. So select. That is a very common one, and it's probably the most used query that you're going to be using throughout this rest of this unit. All right. So how do we insert a new dog named Fido into our table? What keyword are we going to be using again?
Insert.
Very good. Insert. Awesome. And then we say into, and then what's next after that?
My dog table.
Name.
Very good. My dog table or table name. Awesome. And then what comes after that?
Values.
Values. Very good. And then what's after values? The
Bracket.
values, right? It is parentheses and then all of the values within it that we need to insert. As Jason called out, and as we saw prior, if you wanted to customize your inserts, you'll do parentheses after the dog table, denoting which column names you want to insert into, and do those corresponding values below. So that is your insert. Once that happens, then of course, Fido gets inserted into our table and we have a new dog. How exciting. All right, let's keep on going here. So when we do this, what we want to do is say select. I don't know why I did that exactly. There we go. Okay, wow, my animation was completely off here. All right, so I'm just gonna bring this out to you. When we want to actually select information on a conditional, meaning if this information equals this, then bring back those query results, we use the keyword where. Where. So this basically, this where thing, or this where keyword is a lot like using an if statement. You've seen if statements before. They're not going anywhere. Conditionals are a big thing in coding. It's all logic. So if we wanted to see what they look like in an if statement, it's down there below. So is good dog equal to true? That's what exactly this where keyword is denoting there on that line. So we're going to see that real quick. So if I want to select from my dog table where dog ID equals to 1, what I can do is run that and it will just bring us back Stark here. If I only want to get good dogs back, say is good dog to true. There we go, and we'll run that. Now we only get back our second Stark. It's like a good Stark and a bad Stark, whatever that movie is. So we only got back the good Stark here. Awesome. So remember that where, what we have is the conditional that helps us really define our queries. And it's very, very powerful and very useful. Wow, this computer is just not having it today. Let's try to do this again. There we go. There we go. All right. Jeez. All right. So what if we want to add more things to our conditionals? Now remember in if statements, if we want to add more conditionals together, what are the two things that we did? Anybody remember those? We had multiple conditionals that needed to be true. We would put one or two things between it.
And or.
Thank you. I was like trying to say the question without saying the words. Yes, anding and oring. And we can do the exact same thing inside of MySQL. So in this case, I'm going to say is good dog equal to true, or my dog name is equal to Stark. So if I did this, or dog name is equal to Stark, and look how I put those in double quotes there because it is a string. Run that, and now we get back both the good Stark and the evil Stark because both of our dogs' names are Stark. So we got back all those query results. So there we go. Oh my God, you did not. So there, so if we did this in this example, the one that we're looking at in the lecture, I apologize, they're a little bit different there, that our query result would bring back Stark because their name's Stark, because that is true. And then it would bring back Fido because Fido is technically a good dog. And that's another part of our search criteria. So this or is what is allowing us to do that if statement with those or operators in the middle. So this is what that if statement would look like if we were to do it or translate it. All right. Let's keep on going here. So what if we wanted to get back the dog, or what if we just wanted to get back the dog's names? So what if we just wanted to refine our information instead of getting back everything? We just want to get back the dog's names. Well, it's actually a lot simpler than you think. What we need to do is just switch out this asterisk for the column that we want back. So we'd say select dog name, and then with all this criteria, and what it's going to do is it's going to refine that and bring back just the dog names. Now, if you're asking yourself how to do it like with multiple columns, what you do is it's comma delimited. So you say dog name, comma, dog age, etc. So let's go ahead and I'm thinking that that's just broken. So let's go and do that. So we say select a dog name. I'm gonna run that and we should get back 2 different Starks. There we go, we get Stark and Stark. So does Excel use a lot of the same library commands as MySQL? Technically there's a lot of correlation. Just because that I believe SQL is an older language and Excel was, I forgot what the history is behind it, but yeah, there's a lot of cross. But remember that SQL is a querying language and a data saving language, and Excel is more on mathematical side with data. So sum and things like that might not work in SQL. Good question. Good question. Awesome. So that brings back that. Cool. What? So like I said, if we want to bring back the dog's name and the age back, what we're going to do there is that dog's name is going to be comma delimited with dog age. So we say dog name, comma, dog age there. When we run that query, what's going to come back is that it's going to come back dog age and the dog name in one query result. This is a very popular thing to do because tables out there can have 50 columns long. I deal with those in my daily job. They're not fun. So refining it down to the exact columns that I need really does help me looking for the data that I need to use. So this is a really popular tool or popular way of writing a query. All right, keep going. We're digging a little bit deeper here. What if we wanted more information about the dog's owners? All right, it's a little bit different now. If we know my name is Kyle and then I have a friend, Sarah, that owns Fido. Okay, that's cool. But what if we wanted to get even more granular about our owners here? So what if I had Kyle and Sarah there? And Kyle and Sarah are in an owner table, so a completely separate table here. And they're in St. Louis and Sarah's in San Diego, and then they have those owners' age. We just got a lot more information about our owners. Now, these are 2 different tables. So how exactly do we actually attach this information together? Real quick, I got a question. When I use insert into table name, do I always have to specify the columns? With big tables, wouldn't that be too tedious? You don't have to specify all the columns right off the start. Remember, we can use our alter later. So you just have to at least have a few columns, at least the identification column at the bare minimum. But if you don't have the column names for that table, then the table might not be ready to be built yet. But we should at least have some understanding before it is constructed. Awesome question there. All right, so how do we actually attach them? We're gonna learn another keyword, go figure. And this one is gonna be called join. Join is how we're actually going to combine these 2 tables together and share information. Now, the fun part about this one is that is all for next week. But there is your cliffhanger for right now. So if you want to look into something and get a little ahead, feel free to look at join, but I'm excited because now we get to attach our information and actually get it all tangled together and create a system of data that is actually useful for something. Mark, I hope that that answer helps out. If it didn't, let me know and we can go a different direction with it. But any final questions about SQL? Because we didn't learn that much today, right? We just learned a whole new language. So any questions at all? Okay. Then Mark, go ahead and ask your question now because we are at the end.
Okay, so in the text, it seemed like if you just wanted to add a new row, you could just say insert into, and then give the name of the table. And then in parentheses, you put values, and in parentheses, you put the data. But when I was doing it in the exercises, I always had, even if I was filling every column, I still had to say insert into table name, and then name every single column. And so if you have a table that's large with like 50 columns, would you literally, if you just want to add one record, you have to manually type out the names of all 50 columns?
So we saw that we do not have to do that. If you know all the data for every single column and you don't want to do a custom insert, you don't have to put all the names of all the columns. You can just put the values on the value line.
Okay, I tried that and it just didn't work for me. So I don't know what I was doing wrong.
Okay, double check your error and check out what it says. If it still doesn't work, send me over the error and we can see what it is.
Okay.
But to answer your question about those 50 columns and everything, still entering in 50 bits of information is still tedious. So what I want to get at with your question is that this is not how databases are created and set up and maintained.
Okay.
And we're learning this because this is giving us the understanding to go above and beyond so we can have our applications do the hard parts for us. But first we need to know what it's doing. So our applications, our Java server, will actually be doing most of these commands for us in the future. Of course, this is all foreshadowing about what we're gonna be learning, but we first need to get into the thick of it ourselves before we can actually have our applications take over. So just rest assured that if you ever want to become a database engineer, you don't necessarily have to do this every single day. But yeah, there are easier ways to do it, but we have to first learn the hard way first. So great question there. And I'm happy I got to explain just a little bit more on that.
Okay, thanks.
Absolutely. Where do the files save to? Andrew, are you talking about the SQL files? Actually, I don't know where the default for the SQL file is. Let's see. I wanted to save this query, get out of my way. Okay, so if I was going to save this query, I'm going to go up here and click this little save button. It looks like, well, for Macs, it'll just tell me where it goes. So it says desktop. Are you talking about where the data for the actual database is stored? Yeah, okay, so the schemas and everything. If you ever played a video game, when you click save on your video game, you don't have files just sitting out of where your progress is. It's all within the application. The same with MySQL Workbench. Your information is inside of the application. So it's in all of its program files, all optimized and pretty for its use. So the database can stay optimized and maintain itself. So to answer your question, it's most likely in the application folder of MySQL Workbench. Or for wherever that is, but specifically in how it's all structured, zero idea. I have never had to lift up the hood of MySQL Workbench and not looking forward to doing so. So don't exactly know what its structure is on its back end. Yeah, so when it comes to saved, what it does is it takes your information, optimizes it in the best saving pattern possible to minimize space, and puts it into its own own container system, essentially, on your computer. Because your computer right now is the database. So Andrew, I know it's probably not what you were looking for there, but does that help out a little bit?
Yeah,
we
totally.
can dive into it. Okay, cool. Yeah, never really know where that goes. My databases are in the cloud, so I'm assuming they just deal with all that. Whatever. All right. Any other questions we got on this? Anything else? I'm gonna go ahead and maximize this code here. Anything? Where are we at? Okay. All right. Well, if not, thank you for joining me for another edition of Kyle Codes with you all. Have a fantastic week, everybody. Enjoy SQL tonight. The studio will be out at 8:15. Feel free to check it out. If you have any questions, you can always reach out to me. Other than that, stay safe, stay healthy, and I will see you all back here on Thursday. Thanks, everyone.